Hi everyone, welcome to my channel Code with Ease by Varsha. When we talk of system design, there are essentially two parts to it. One is the high level system design and one is the low level design. We will talk about the high level system design. Low level system design is more boiling down to the code, the class diagrams, sequence diagrams, and all the diagrams that you need to do to actually architect what the classes will be, what are your methods, and everything. That we will not talk about today. We will talk about high level system design. What is high level system design? Where you have to think from an architect perspective, in which you have certain requirements, the functional requirements, the non-functional requirements, and based on the requirements, you have to design the several modules of your system, how the different parts of the system are going to work together. So you have your servers, your request will be coming to the servers. After the request come to the servers, where it is going to be, is there going to be any middleman, any middle module that you're going to put your request to? What about the databases? What will be the type of databases and so on? So if you have to do all of these things together, you have to understand about the building blocks. And those building blocks are something like most commonly heard load balancer, message queues, content delivery network or CDN, reverse proxy, and so on. Now, traditionally, there are two ways of doing this. Either you first learn to design how to design a maybe how to design a YouTube, how to design a URL shortening system, how to design Twitter, how to design Uber. That is one approach of learning it. Or you learn about the building blocks from scratch. What is CDN? What is load balancer? What is message queue? Or the third way, the one which I'm going to discuss today, is going to be like reverse engineer and approach it with a problem statement point of view. That given a problem, given a scenario, which building block or which component of the system design am I going to use? Am I going to use this component? Am I going to use this component or this component? In that way, what happens is when you approach it from a problem statement view, you basically try to understand in a very clear manner where to use which building block and where not to use a building block. That is very important when you're trying to design a system. With that, let's begin. Let's begin the 15 system design components today. Request across multiple servers, but now you're getting slower response time. So now it is time to introduce a CDN. So this is how you gradually increase your understanding of system design by understanding it block by block by solution for achieving this goal. Content delivery efficiency. Your YouTube is doing what? It is delivering the content. I am a content creator. I'm creating content. It is delivering the content. Now you cannot communicate. What can we do? Something we have to sacrifice. What we can sacrifice? The availability, which means we have to shut down all these inconsistent nodes. The nodes which don't have the latest data needs to be. Starting with the first question. Your website experiences a sudden surge in traffic, causing it to slow down. Which technology can you implement to evenly distribute the incoming traffic across multiple servers? So you have to talk about which technology, which building block, which component is going to be used. What are the keywords over here? Sudden surge in traffic, like you can think of like Great Indian Festival of Amazon. And then you need to evenly distribute the incoming traffic. So these are the two keywords that you have to understand. We'll be having options also, but you can also think at the back of your mind. What is the correct answer for this? The correct answer for this is a load balancer. Why? Because whenever you have a surge in traffic, so what actually happens is you have a web server. Okay. So initially there was one web server, you have user, you have some DB over here. Okay. And the web server is trying to query from the DB, get the data what is needed and serving to the user. So it will go in here, will come over here, and then finally it goes to the user. But as and when your user base increases, you need to add more and more web servers to serve the growing base of users. As and when your user base is growing, you're adding up web servers. Now the question is, when the user requests are coming, like millions of requests are coming, which server will it go to? Which server will be delegated the request to? That is why it is saying to evenly distribute incoming network, there should be a middleman. And that middleman is nothing but the load balancer, or we call it LB. So I don't want to burden just one single server. I have to distribute my 1 million requests between all the servers that I have. If I divide the request equally between all the available servers, then I will be able to get faster response time. If I get faster response time, what am I trying to achieve? I'm achieving scalability. I'm able to scale my application more. I'm going to also increase my availability. The application is going to be available most of the times. And also I'm trying to improve the performance. These are the key things when you are having a surge in traffic. These are the key things that you need. So load balancer can intelligently route the incoming requests to different servers. There are certain algorithms that is like going one level deep into load balancer. So a good example of a LB would be the one which many of us used, an Nginx server. We use, in case of AWS, we use AWS Elastic Load Balancer. There is application load balancer. There is network load balancer, each serving its own use case. So we first learned about this first basic building block called the load balancer. Next is your website is experiencing a spike in the malicious bot traffic leading to server overload. Which tool can help to mitigate this issue by enforcing access limits? Bot traffic. Okay. Now let's say there is a term which we always call DOS attacks, or maybe DDoS attacks, which is called denial of service attacks. So whenever there is an unwarranted traffic which is not coming from legitimate users, but somebody is trying to intercept your servers and do it malicious attempt in order to block your server or block your application from being accessible to the public internet, then in that case, what can you do so that this kind of denial of service, it is like you're denying the service to the legitimate user. That is why it's called DOS attack. So you are trying to deny the service. So what can you do to enforce this access limit so that there should be legitimate users coming in only? These are the options. The correct answer for this is called rate limiter. Why? Rate limiter will help to control the rate of request so that which is sent to a server or the service. It enforces access limit by allowing only certain number of requests per unit of time. Certain number of requests per unit of time is the important thing. It can come from particular client, IP, or other factor. There are many rate limiting algorithms also. Okay. So it is, you can think of it like it is a defense mechanism in case of your application or your server, which is going to disallow the flooding of request. That is what we want to prevent, the malicious bot attack that we want to prevent. Why this is like a defense? It is trying to set a limit per unit time, and thus control the data flow. So you have to understand, it is like a defense mechanism acting like a guard, setting a limit for the number of requests per unit time. Okay, so that the data flow can be controlled. If you see, a very simple example will be in case of Twitter or X. There is, I'm not sure now, but there was a limit of like 300 tweets in a day. And probably this is the capping that it had, that there should only be 300 tweets in a day. In fact, there is also something called API rate limiting. Whenever you try to use any third-party API, right? Let's say you are using OpenAI, you're trying to integrate OpenAI APIs into your application. There is also a rate limiting factor that per minute you can send only 5 requests or 10 requests and not more than that. In an effort to enhance content delivery efficiency, you aim to cache your regularly accessed assets nearer to your users. What would be the most suitable solution for achieving this goal? Content delivery efficiency. Your YouTube is doing what? It is delivering the content. I am a content creator. I'm creating content. It is delivering the content. Now you are seeing the creator's content. The creator has made the content in US, and you are being able to sit in India and able to see the content in India by streaming the video, and you're able to see that seamlessly. So all the assets like the images, the videos, the JavaScript files, the HTML files, all of these are called assets. Anything which build up that particular content, right? Now all of that is being cached in some location. You have to understand caching is a basic mechanism. Like we have a cache in a computer where it is the section of the memory using which we have faster retrieval time. So by caching that nearer to your user, you are able to increase the efficiency. Like you are able to have a smooth playback experience when you are trying to stream on YouTube. How is it possible? Using what technology is it possible? The technology is called CDN, or Content Delivery Network. What it does, it employs a network, because it is called network of geographically dispersed servers at a different geographical location, ensuring quick access to the content regardless of user location. So you don't care. I am creating content in India. People sitting in Europe and US are also watching it seamlessly. All the static content, images, videos, scripts, style sheets, are put on the edge servers at the key locations to minimize the latency. So CDN should be synchronous. Whenever you talk of CDN, it should be synchronous to one thing which is called latency it should be synchronous to one thing called cache content, cache the static content. So the main point of using CDN is to reduce the latency. So what is CDN composed of? It is composed of a network of server. Why it is used to reduce the latency? How it does it? How it reduce the latency is by caching all the static content. This is how, in case of YouTube, you are able to see the high quality streaming content. The work of CDN is to store the content and also to deliver the content. Okay. How it caches the content at the edge locations. There are certain edge locations or the edge servers at some key locations, like in India, probably it is in Mumbai, probably it is in Delhi. We are not sure. So it will try to keep in those locations from where it is easy to access. What are the examples of CDN which is used industry-wide? One of the oldest is called Akamai. In case of Amazon, we have AWS CloudFront, very, very popular. If you try to Google it out on CloudFront, whenever we talk of CDN, AWS CloudFront is always one very popular choice these days. Your web application requires a scalable solution for storing unstructured data, such as user-generated content. What service should you use? Do you have to store the unstructured data? What service should you use? If you have to store, you have to persist it, right? So it should be some kind of DB. What is that DB going to be? The right answer is blob storage. Okay. So what is a blob storage? What is blob? First of all, you have to understand what does BLOB start for. It is called binary large object. Anything which is unstructured, your audio, video, photos, which do not necessarily have any relational data or doesn't necessarily have any hierarchical data, no hierarchy, like flat data. Those are called the unstructured data. And now, in the days when big data became popular, this kind of data, terabytes and petabytes of data, became largely popular. All the big companies, be it Amazon, Facebook, Microsoft, Google, everyone is trying to stream terabytes, petabytes of data. Probably every single day, they are trying to store that much of data, right? So there's enormous amount of data, there's enormous amount of unstructured data which is coming in every day, and we have to store it. We cannot use normal MySQL DB or Oracle DB or normal relational data. For that, we have to use blob storage, right? So what are the industry-wide use over here? Like the services is called in S3, AWS S3. Your company is experiencing frequent database overload. Sorry. Let me just erase this. Your company is experiencing frequent database overload due to an increase in the user activity. Which technique involves partitioning the database into smaller subset, and distributing them across multiple servers? So this issue is something similar to we had the web servers. We tried to have multiple servers, and that term is called horizontal scalability. We're increasing the number of servers when there was increase in the traffic. Now you had also database. Now the database is getting overloaded, so you're trying to partition the database into smaller subset. But how do you want to partition it? Why do you want to partition it? Let's talk about that. So these are the options. Vertical sharding, horizontal key-based sharding, range-based sharding. Okay, so the right answer for this is horizontal sharding. What is sharding, or what is called database partitioning? Okay, we partition the DB into smaller subset like it is told, and we distribute. So for example, your database has 1,000 rows. So you can do it in two ways. How can you, it will have 1,000 rows and it has 5 columns. How can you partition it? Either row wise or column wise. If you do it row wise, we call it horizontal sharding. If you do it column wise, we call it vertical sharding. Firstly, now you want to partition it into a smaller subset and distribute it across the multiple servers to distribute the workload. So I can say like row number 1 to 100 will be on one server, 101 to 200 will be in another server. So down this partitioning that you're doing, we are going to say that we are going to store that in every shard. So that is where the term sharding is coming. You're just trying to shard it. So what can be the reason for this is, the major reason is to reduce the database overload, so that you don't have to, whenever you're trying to do any CRUD operation, you don't have to go through this all the 1,000 rows. You can have your small subset, your lookup data set can be this much, only 100 rows, so that you can have faster response time. You can reduce the database overload. one example could be that you're trying to store the 100 rows in one server. Like maybe you can do it like you can partition it based on the region, like the users of region, let's say India. We were trying to partition all the users of India, then all the users of Singapore, then all the users of maybe US, like that. We're trying to partition it based on geographic location or geographic region, which can help us to allow for better distribution of workload and improve scalability. So based on that kind of partitioning, so now we understood this is how database partitioning is done, and the name is called sharding or database partitioning. And the right answer for this was horizontal sharding, because we are trying to do it row wise. When would you want to do it column wise? Probably you have 5 columns, right? So for faster retrieval, let's say you have name and you have some email and you have some other fields also, but you know that the most frequent one is name and email. So you put this entire data set of just name and email by doing a vertical sharding in one server, and maybe the other columns, column 3 and 4, maybe in another server. Your application needs to compress files before transmission over network. Which component would you use for compressing the data into smaller format? This is simple. Okay, so you just have to compress the data to optimize on the memory storage. What would you use? An encoder. What does encoding do? It refers to the process of converting data from one format to another for the goal of reducing the size. Okay, one very popular use case of this is in YouTube. When I am uploading my content is, let's say, 600 MB of size, but it will not try to take up 600 MB, because what it does, it tries to compress this data. It tries to compress it. Let's say it makes it into 100 MB. Okay, by doing this, it is optimizing on the storage space. So that is why we need encoder. So YouTube and encoder is a very good use case. I have also written a very detailed article on YouTube. How does YouTube stream data for millions of users? The link to the system design articles that I'm writing on Medium is going to be in the description, so you can check that out. Okay, your e-commerce website experiences high traffic, again high traffic during sales season, leading to slower response time. Okay, so which technology can help to cache the static content and improve the website performance during these peak periods? So there is a traffic again increase in the sales event, but it is causing slow response time. So we need to remediate it. What can we use it? This question is something similar to what we have already done before. Cache the static content, and that is the right answer is CDN. We have already talked about CDN, that how we can improve. So this is like a problem statement for you. You have used your load balancer to evenly distribute your request across multiple servers, but now you're getting slow response time. So now it is time to introduce a CDN. So this is how you gradually increase your understanding of system design, by understanding it block by block, by understanding it component by component. Moving to the next one, you are scaling a database system and considering partitioning your data across multiple nodes, okay, based on a predefined attribute. What technique should you employ? So these are again the types of sharding. You're trying to partition it based on some predefined attribute. Okay, so what kind of sharding technique? Because there are many different sharding techniques. We talked about vertical and horizontal. There are other sharding techniques also. The right answer for this is called key-based sharding, where you're doing this on the basis of a predefined key. And the shard, the partition or the subset of the shard, it's used interchangeably, are going to contain the data which corresponds to that specific range or a set of keys. It can be on one key also, it can be on multiple keys also. So there are many different types of sharding, like key-based sharding. It is also called range-based sharding. That range-based sharding is like you want to do it on a particular timestamp, or maybe on some alphanumeric characters. That is also you can do. Key based is more like I said, the geolocation based sharding, right? So it is like a subset of the horizontal sharding only, but the names are different. You are designing a highly available system where network partitions are unavoidable. What principle states that it is impossible to achieve perfect consistency availability partition tolerance? A very classic example of a very classic theorem. Over here, you can try to think of it. The answer lies in the question only, and the right answer is CAP theorem. Consistency, availability, partition tolerance. What does it say? That it is impossible to achieve all the three things together. You have to understand this trade-off. It can be either CA, or it can be AP, or it can be CP. Three possible combination: consistency, availability, partition tolerance, or consistency and partition tolerance. It is consistency. Consistency means all the nodes will be able to see the data. In case of financial transactions, this is very important. you are trying to deposit or withdraw the system. Everywhere else, if you try to see, the transaction should reflect immediately. That there should be consistency in the financial transaction that you're doing. So all the nodes see the same data. Okay. Consistency is also having its types, like strong consistency or eventual consistency. We'll talk about it later. What is availability? As the name suggests, your response, okay, every request is trying to get the response even when the service is down. It should be operational. Your system should be operational. Otherwise, we call there's a it's a downtime happening when your service itself is down, and you do not want that. Even if some exception is happening, you want it to be operational and to be handled it accordingly. It should not be like a blackout. P, partition tolerance. So there will always be some network fault. So that is what we are talking of. If there is failures, it should continue to operate even if there are network failures. So that is combination of all of these three is called CAP. Now together you cannot have all the three things. So now CAP theorem states that only 2 out of 3 principles of this is possible. Either it is CA or it is AP or it is CP. Any two will be possible at a given time. If I talk of CP, it means consistency and partition tolerance both. See, partition tolerance you cannot really avoid. Everywhere you go, network faults, network issues will always happen. So whenever a network issue happens, there is a set of nodes here, there's a set of nodes here. If there's a network issue happen, these set of nodes will not be able to communicate. The communication itself will stop. So now imagine if the communication itself is stopped, now these set of nodes got updated with the correct data, with the latest data, these didn't get updated. And you cannot synchronize, you cannot replicate the data also to ensure the consistency. So in case of partition tolerance, ensuring consistency is important. So in case of partition tolerance, if at all you have to ensure consistency, means they have to communicate with each other. But if they cannot communicate, what can we do? Something we have to sacrifice. What we can sacrifice? The availability, which means we have to shut down all these inconsistent nodes. The nodes which don't have the latest data needs to be shut down, which means we are sacrificing the availability, thus ensuring consistency and partition tolerance. What about AP? Now, just the reverse. Now you want to say that, okay, I cannot sacrifice availability. I will continue to show the stale data along with the new data. These nodes will show the correct data, the new data, and these nodes will show the old data. Sometimes you may also see that sometimes maybe in WhatsApp, your stale data is coming, your older message conversations are coming, whereas the latest is not getting synced. The consistency is not being established. It is called eventually consistent. Anyway, that is out of the scope for this. So that is what I'm saying. With P, you can either have C or you can either have A, not all the three together. That is why CAP theorem together, CAP is not possible. Either with P you have C or with P you have A. CA is technically not possible. Why? Because now imagine this scenario again. Partition tolerance. Partitions have happened. To ensure consistency, you have to shut down the non-consistent nodes. Now, if you want to have consistency and availability also, it is not possible. You have to you have to shut down the inconsistent nodes, thus you are sacrificing for the availability. And if you have to keep all the things available, all the nodes available, somehow you are sacrificing the consistency only because the nodes didn't get synchronized. They didn't get synchronized with the latest data. So that is why CA is technically not possible. But although there are databases which does ensure CA, but it is technically not always possible. Somewhere or the other, either your availability will go for a toss or your consistency will go for a toss. Moving to the next question, it's related to your distributed system experiences network partition leading to temporary communication failures between nodes. Which principle of CAP theorem suggests that system should remain operational despite the network failures? We have just now discussed about it, and that is availability, right? That it has to remain operational despite your network failure that it happened. It has to remain operational, means all the nodes on this side and all the nodes on this side will be available. You are designing a distributed system where data consistency is crucial and network partitions are expected to occur. Which CAP theorem suggests that system should maintain consistency even in the presence of network failures? We just now discussed about it. Now you have to think and answer which of these principles will be satisfied with this. I want to ensure consistency and there will be also network failures. What will I have to sacrifice? I will have to sacrifice the A. So I have to choose C and P. So the right answer is CP. Next is, you are implementing a system where multiple subscribers need to receive updates from publishers asynchronously. Okay, multiple subscribers need to receive updates from publishers asynchronously. Which communication model should you use to achieve? Now, this is a new topic. It is called the pub sub publisher subscriber model. So, what happens over here is, okay, firstly, these are the answers, these are the options, and you have to choose which is the right one. Think about it. So, pub sub is a asynchronous communication technique. Okay, what do we say asynchronous means? Nobody is waiting for nobody. Like, in case of WhatsApp, when you and your friend are texting each other and you're in the same chat, you're just chatting with one friend, you are waiting for your friend to answer, your friend is waiting for you to answer, but you send an email. You send an email to a friend who is staying abroad, and you literally do not wait for that person, for your friend to come back and reply you instantly, right? It's not instant messaging. So this is a difference. Instant messaging versus your email. Email is your asynchronous communication. You do not really wait. Similarly, in case of this, your subscribers need to receive the update, but they have to do that asynchronously. So what kind of model should you use? The right answer for this is called fan out model. Okay. Pub sub model, pub fan out model is similar, but let's try to understand the basic. What is pub sub? Pub sub is the publisher subscriber model used for asynchronous communication. Okay. Now, what happens is, let's say there's a queue over here. You have a publisher and you have subscriber. You can have one subscriber, can have multiple subscriber. If you have multiple subscriber, that is why we say it is like a fan out model. Okay, something like this. So your publisher is trying to put data into it, and your subscriber has subscribed to this particular queue, like you subscribe to a newspaper. So you get the newspapers delivered. Similarly, you get the messages delivered as a subscriber. Okay, you're not waiting for the messages. Actually, whenever there is a message being dropped, you poll for it and you get the message. It can be, now when we talk of fan out model, it's like your single messages is broadcasted to multiple subscribers. That is why we call it like the fan out model. Okay, messages are broadcasted from a single source to a multiple destination. Now, this model ensures that all the subscribers receive the update without the need for direct integration. There is no direct interaction that this publisher is trying to put over here, the subscriber is hitting a REST API and getting the data, nothing of that sort. It is, okay, so what are the terms you have to understand? One is asynchronous communication. Another term is called decoupling. Whenever these terms come in now, you have to understand that pub sub model is the requirement over here, or the fan out model is the requirement over here. Asynchronous communication, decoupling, you're trying to decouple the publisher and the subscriber from each other. There's no dependency between each, and both of them are working independently. So you have a queue or message broker. Okay, maybe you have a AWS SQS in AWS, or you have a Kafka. These are the middle layer. Your publishers are trying to put data into this, and your subscribers have subscribed. Whenever there is a put message done, you are able to get the message over here. So the next question is, you are architecting a database system for a mission critical application that needs to ensure high availability and fault tolerance. What technique should you use to maintain multiple copies of the database? This is a new concept. Multiple copies of the database is the main keyword over there. These are the options. What is the right answer? As you can guess, we have to maintain multiple copies. So it is like cloning or a replication technique. So the right answer for this is database replication. So what does database replication mean is, you took data and you are trying to maintain multiple copies of it. You're replicating it. And that is what it means. You're replicating it across multiple servers or nodes to ensure the high availability and fault tolerance. So a very basic example would be like, if you're trying to replicate a data, what is the major thing that it is helping you with? It helps you with disaster recovery. So if one of the server goes down with all of its data that it has gone down, then you have the backup of the data in other places, in other servers, which you can serve. So this is the main objective. And when you do this, automatically you are ensuring the high availability, because your system is going to be operational. Even if one of the server has gone down with all the data, it is automatically becoming operational, high availability, disaster recovery, and therefore it is fault tolerant. The basic thing of database replication is not just keeping a backup of the data. So it will copy the data into multiple, but it is also going to synchronize the data. Synchronize the data as in to maintain the consistency of the data across all the multiple servers. This is the new building block that we learned about database replication. Moving on. Your website experiences high traffic during peak hours, leading to slow response time. What technology would you implement to improve the performance by caching frequently accessed data closer to the user? Now, you might think of CDN because that is what we have talked about so far, but the right answer for this as per the options given here, would be Nginx reverse proxy. Now you'd be like, why are we using Nginx reverse proxy? Okay, so we talked about Nginx, right? So it was one of the, it is used, the Nginx servers are being used as load balancer also, and we have another term called reverse proxy. We will talk about proxy servers also in some time. So proxy servers are like, they sit in between your client and the servers, acting as an intermediary. So Nginx is also doing that. Now, it has multiple use cases. The use case that we are talking about here is caching the frequently accessed data. So it acts as a front-end server that can cache all of this, reducing the response time, blah, blah. Now, when do you want to use, the biggest question is, when do you want to use the Nginx reverse proxy versus when do you want to use CDN? So as we know, CDN is a distributed network of servers, which is also managed mostly by third party, like AWS is going to manage the cloud front. But if you are like, you want your data to, if you want to host plus manage your infrastructure in your on-premises, so you are going to deploy this and you are going to manage the caching, the security policy, the load balancing techniques, the access control policies, everything you want to maintain on your own. You want to host it and you want to manage all the infra. In that case, you should be using Nginx reverse proxy without relying on a third-party CDN. So in that case, even this use case of caching the static content and all will be handled by the Nginx reverse proxy only without you being using CDN. CDN is more on a global edge server or from like multiple various geographical locations you're going to access it. So from a global perspective, CDN is useful. But if you want to manage it on your own, then Nginx reverse proxy. So that is the reason why I have included this question. Your application requires a messaging system where messages are published to multiple subscribers asynchronously. Which messaging model would you choose for this scenario? We've already discussed about this. I've just included it so that it can be like a revision for you. So we know the answer for this is PubSub messaging model. Always remember the keywords. Messages are published to topics. Multiple subscribers have subscribed to that topic so that they can asynchronously receive the messages. Well suited for scenarios where single publisher needs to broadcast or distribute the messages through a message broker to multiple subscribers without direct intervention or direct interaction. This is what is PubSub model about. You are designing a monitoring system for a distributed app. Which mechanism should you implement to regularly check the health status of individual components and detect failures quickly? So these are the options. You need to do a health check. So what is the right component to do that? There's a mechanism called heartbeat mechanism, where a periodic signal is sent by the component of the distributed application to indicate whether it is operational or if it is alive and functioning properly. So this is basically for what property? For checking, like for ensuring the availability. That is why we are periodically sending the signals between the devices if they're operational and to monitor the health. Okay. So that is what heartbeat is all about. For checking the heartbeat signals and can quickly detect. So if there is any anomaly, like for example, if your service is working fine, it will periodically check that, okay, it is doing good. If it is not, because of the signal it will release, it can either raise alerts, it can either do something that it is that the request should not be going to your that particular server anymore. So all the fallback mechanisms can be taken care of. You are developing a microservice architecture need to prevent cascading failures when one service becomes overwhelmed. What pattern should you implement to temporarily stop requests to a failing service? This is something related to distributed system patterns or microservices pattern, a very important pattern when it comes to high-level system design, and that is called circuit breaker pattern. This is the right answer for this. It's a microservice pattern. Like it is said that when one service gets overwhelmed, okay. Now, what is the basis of this? What is the motivation? Like at our home, you might have seen there are electrical circuits where we have MCBs, miniature circuit breakers. So whenever there's a power surge, the circuit will trip and will stop the flow of electricity so that no damage is done to any of the appliances. Similarly, you will also have this kind of circuit breaker that there are multiple services and there's a circuit breaker, okay, which is applied. Now, whenever it detects that there is some anomaly, like maybe slower response, some error is happening, the response is slow, some resources have exhausted, any of this issue, it is going to trip and it is not going to accept it is going to detect that the service is failing or responding slowly, and then automatically the load balancer will stop sending requests to that particular service. I'm not going much deeper, but just try to remember it is a circuit breaker is a design pattern in which we try to detect not on the network level, but on the application level, like internally going into the intricacies of what exactly is going wrong. And basically on the basis of that, we take a call and we ensure that we don't send requests to that particular service. So you break out. So you break the circuit over there. Hence the name circuit break. Next question, you're designing an API endpoint for processing financial transactions and want to ensure that duplicate results requests do not result in unintended actions. What property should you enforce to allow the same request to be processed multiple times without side effects? So these are the answers. These are the options. So what is a property that will ensure that there is no duplication of the same request or maybe incorrect processing of the same request? The right answer for this is called idempotency. Idempotency. So like I work in fintech, right? So we usually get multiple transactions and we have to ensure that we do not incorrectly process one transaction twice or maybe multiple times. So we always have to check if this particular transaction ID or whatever ID, some unique identifier has already been processed or not, whether we check in DB or cache, whatever the business logic is, but we always have to ensure that it is either it is processed, we maintain some flag. If it is not processed, then only we will take it. So multiple different things. So the main point we want to ensure over, we want to say that idempotency is something which you have to ensure that, which will ensure that the same request, if it is processed multiple times also, it is not going to create any duplicate entries like, let's say, in the DB. So it should not be like causing any unintended actions. A user can press the submit button multiple times, but that doesn't mean that because the user is pressing the submit button multiple times, you are going to create duplicate entries in your persistence. So by making the API endpoint idempotent, we have to ensure that this even if it is received multiple times, only single action is being performed. You are ensuring, moving on to the next one, you are ensuring high availability fault tolerance. What technique should you use to maintain multiple synchronized copies of data across different locations? We already talked about this. Multiple synchronized copies is the main clue over here, and that is database replication, where we have talked about it is not just to have a backup, it is not just to have a copy, but to also synchronize the data to ensure the consistency so that none of the servers have out of sync or stale data. So that is the main point. You're designing a backup strategy for your critical data. What approach should you take to create duplicate copies of data to ensure its availability in case of failures? Now, you may think of database data replication, but that is not the right answer over here. The right answer over here is data redundancy. So the first question that might come is what is this and why is it different from, how is it different from data replication? So data redundancy involves creating duplicate copies to ensure availability. This is also going to ensure availability. This is also going to ensure the fault tolerance. By having redundant copies of data stored in different locations, you mitigate the risk of data loss due to hardware failures, disaster, crash, any hazard, whatever, calamity. Okay. Now, how is this different from data replication, database replication? Redundancy can be achieved through a primary way of simply having a backup, multiple backups, mirroring, clustering, RAIDs, whatever. There can be multiple backups you can create, but not necessarily that all your backups are always synchronized. So, when you have some spare components or spare parts or backup components ready who do not necessarily take part in the transaction in your day-to-day transaction, that kind of components are usually part of the data redundancy. They're not actively part of it. Whenever your failure occurs on one of the component, then all these backups will take over. Then only we are going to make the backup. So whenever there is any failure happening, only then these backups will take over in case of any outage. So otherwise, these backup components are unutilized. But in case of data replication, you are having several copies which are also synchronized. So you're syncing the data across all the copies, across this. So even in your day-to-day transaction, these copies are remaining active and they're very much participating in your day-to-day transaction because they are getting the data synced across. They also will take over whenever there is an outage or a failure. But the biggest difference is this. They are actively part of the transactions because they're getting synced. The backups may not be getting synced. They're just like staying idle or just as spare parts we have. Next, you are scaling a large database system to handle increased traffic and storage requirements. What technique should you use to horizontally partition the data across multiple database instances? I think we have talked about this horizontal partitioning, increased traffic, and the right answer for this is database sharding. Next, you're designing a network infra to improve the security and performance for internal users accessing external resources. Internal users accessing external resources. What component should you deploy to act as an intermediary between client request and external servers? You want to improve the security and you want to improve the performance. So, what component will be acting as an intermediary to improve the security and the performance? Right answer is proxy server. Like I said, it is going to act as an intermediary, sitting in between. This is the client, this is the server, it is sitting in between. It has a lot of different tasks, right from intercepting the request, forwarding them to the external servers, caching, filtering malicious traffic, optimizing network performance, content filtering, what traffic should go, what traffic should come in, inspecting the traffic. So, a lot of different things. So, also masking IP addresses, right? So, let's say I'm doing some testing in my Linux servers in my team. And that day I was trying to do some requests to AWS, one of the APIs. And it was not letting me do it because the proxy server was blocking it. Okay, until I have a NAT gateway or I have a proxy server configured to do that, I will not be able to send any request. So for that, I anyway needed to have a VPC endpoint. That is a different story. But the main thing is proxy server is trying to do a bunch of different things by acting as an intermediary. But again, the question is, what is the difference between proxy server and load balancer? Now, if we talk about what is proxy server versus load balancer, well, load balancer was doing many of the things. Proxy server is always working on the application layer. So it will protect the HTTP. It will work with the HTTP, HTTPS protocols. LBs will always work with the network layer. So on the network layer, it will try to identify from where the requests are coming, which IP address, and then accordingly distribute the traffic. The main work of LB is to distribute the traffic to multiple servers, like we said, to improve the scalability and the performance. But the work of proxy server is to handle the request response on behalf of the client. So both of them are doing two different things. LB is to distribute the traffic across multiple backend servers. They work on the transport and the network layer, whereas proxy server is working on the application layer and handling these protocols. This is the thing about proxy server that you have to know and how is it different from LB. You're designing a social media platform where users can post photos, videos, and text updates. What type of database should you use to efficiently store and retrieve this heterogeneous data? Heterogeneous as in dissimilar, not similar, not same type of data. All types of data. Photos is one format, videos is one format, text is one format, comments are again different. So all the things are mixed up together. So what type of database should you be using? The right answer for this is document database. Example would be Mongo database, MongoDB. Okay. Now, two things you have to understand over here. One is you have to understand what is SQL, what is NoSQL, and the difference between these two, where to use which one. And you have to understand what are the types of NoSQL databases. SQL, as we know, the classic relational database having structured data in a tabular format. We have complex queries, joins, everything is there. So in that case, and also ACID compliance, ACID. So all of that are the requirements for a SQL database to be used. But talking of NoSQL data, since the time big data has come in, it has the capability of handling large volumes of unstructured or semi-structured data, which maybe also can be used for real-time application, real-time analytics, big data processing, and anywhere where you have TBs and PBs of data, petabytes and terabytes of data. For all of that use case, you need NoSQL databases. The social media platform is one big, gigantic place where you have enormous, massive amount of data, and most of which are schema-less. They do not have any hierarchy. They do not have any relation as such. All of that are unrelated. So that is why NoSQL DB is the first choice. That is one thing. Second is types of NoSQL. There are many types. One is the document database, which we have just seen. Another is key value pairs. Next is column database, columnar database like Cassandra. And next you have graph database. For key value, we have Amazon, DynamoDB, we have Redis, document, MongoDB. So wherever there's scalability, flexibility are concerned, large volumes of data, we are using NoSQL database. And that is why the answer for this is NoSQL. Now, why are we using a document database and not a key value? Of course, you have all the photos, videos, and text updates are going to get stored as separate documents. That is why document data type is needed. Graph is needed when you have like social media, your friend, your connections in LinkedIn, when that kind of relationships you have, that is not a requirement over here. There is nothing key and value. And columnar database is also not a suitable criteria for this. So what are we left with is the document database. We'll try to do a in-depth video on these use cases, examples, real life examples, real life technologies which uses. So you can comment down below if you're looking forward to that. Now we can move to the next one. You're optimizing database performance for a frequently queried column in a large table. What database feature should you use to speed up the query execution by creating an ordered data structure? The right answer for this is going to be, the clue is over here, frequently queried column. For that, you want to optimize the database performance. The right answer is database index. Where, what is database index? A data structure which improves the speed of data retrieval operations on a table by creating an ordered representation. So you have frequently queried columns, right? So in some cases, we have a where clause. And in where clause, whatever column we are using, that column we try to put up on the index, because we know that again and again that column needs to be used. So it helps us by indexing the most frequently used columns. Okay, it helps us to retrieve the related rows from the table in a faster manner, because it creates a data structure around those particular columns and sorts the values within that. So it helps us in faster retrieval. So like it is said, when a query filters or sorts the data based on that particular indexed column, database can quickly locate the relevant rows. And that is speeding up the performance, speeding up the query execution, thus optimizing the database performance also. So that is why a database index is used. Here is the last question for today. Developing a real-time analytics platform that requires complex querying and join. Very simple. What type of database should you choose to accommodate? We just now discussed about the use case, complex query and join. So blindly, the answer for this is going to be SQL database. Wherever you have joins, relational database, wherever you have joins, aggregations, subqueries, SQL database without any second thought is going to be the first choice. So with that, we are going to wrap up today's session on the 15 system design concepts, or the 15 system design building blocks that you must know. I hope you guys have got sufficient value out of this, as this was just scratching the surface of the system design. So if you're looking forward to part 2 with intermediate questions or intermediate problem statements around this for more experienced developers, we will be happy to do that. So let me know in the comments if you're looking for that also. Thank you so much for watching this video. Do subscribe to the channel if you haven't already, and do like and share the content, and leave us a comment on whatever you're looking forward to next. Thank you so much.